Hello friends, welcome to another video, and we're going to continue doing our functions on past exam question papers. And I can see the response is rather positive. The subscriptions are increasing ever steadily, so that's a good sign that probably someone is benefiting somewhere, and that's the aim. So I'll keep pushing for you guys, and I hope we're going to get the best of results at the end of all of this hard work. Alright, so I've taken this one from September 2021 from the EC, okay? Not too sure whether these papers are provincial papers or the national papers. Whatever it is, we're going to have a look at what was the structure of this paper last year, okay? Now let's have a look at some information provided. So we're told here the diagram below shows the graphs of f of x equals minus 3 over x plus 2 minus 1. Now what do you know when a is less than 0? What should our graph look like? On the Cartesian plane, it's in the second quadrant and fourth quadrants, okay? But of course, these guys here form asymptotes, so essentially the x's are shifted around, horizontally as well as vertically. So, but we expect something like that. Not a problem. So also g of x equals the power. Remember, the power is the whole thing, the base and its exponent. So it's the power of base b to exponent x, okay? Again here, what do we know? We know that our a is equal to 1, isn't it? And that is greater than 0. Because when it's not written, it's greater than 0. So what do we expect? This graph is not shifted, so it's the standard graph. So we expect this graph above the horizontal asymptote. And that asymptote is the line y equals 0, which is the x-axis. Okay, not a problem. So let's just pause there for a second. Okay, let's have a look. Now, if I was the examiner, I would truly not label these graphs, because I would rather have the student identify them. Because as you can see from just theory, you would know which graph is which here. So we saw that this is in the second quadrant as well as the fourth quadrant. So it cannot be anything but the hyperbolic function. Of course, these form our asymptotes. Now if we observe here, well, a vertical asymptote, you always take that denominator, equate it to 0 and solve for x. So when you solve for x, then we get minus 2. So we know here that we have minus 2. So that line is the line x equals minus 2. And then we know that this is the horizontal asymptote, so it should be minus 1, right? Exactly as it is over there. So clearly, we can see this graph is getting closer to these lines, but never crossing them. So what else could it be? In this case, it's only the hyperbolic function. Great. Then we said, fine, what about the exponential graph? Well, we saw that this graph comes down closer to the x-axis, but it never crosses them. So it tells us that this becomes the horizontal asymptote of this graph. And this graph is appearing above the horizontal asymptote because our a was greater than 0. In essence, in this case, it's just 1. Alright, not a problem. But what do we know? B is greater than 0. Okay, that's another restriction they're giving us. But what else do we know? We can note that as we move from left to right, this graph is decreasing. So if it is decreasing, in addition to that b greater than 0, we know that b is also less than 1 for a decreasing function. Okay, so that's enough interpretation. So a and c are x and y intercepts of f respectively, and you can see that there is point A and there is point C. So being the x and the y intercepts respectively, while d is the y intercept of g. Okay, again, this one you need to know that at this point we have 1. Okay, so it's 0 and 1, but you will see why it is so. And then point E, which is 3:1/8, is a point that lies on G. Okay, there it is. We don't have to say too much. So these are our graphs. So if ever they were not identified, now from all the theoretical interpretation of what we are given, we could essentially identify that this indeed is a graph of G. So there's no manga business thing. Remember, sometimes these things can be reflected about the axis, so you need to know and identify that that is what has happened, because at times they will give you something but present something on the graph. Then you need to know what is the relationship of what you will see on the graph versus what has been given. So in this case, you prove that what is given is exactly what is drawn. So there's no tricks anyway. Now let's go and deal with these questions. What do they want? So they say write down the coordinates of D. See, they're saying write, meaning you don't have to calculate. So let's do this quickly, nice and easy. Okay, so what we've got here is the EC September 2021 paper 1. Okay. I like to identify my question papers so that at least you know where we are. Alright, so this is question 4. So what is given is f of x equals -3/x plus 2 minus 1. Right, that is the hyperbola. With a less than 0, then we expect the graph in the second and fourth quadrants. And we are also given g of x equals the power of base b to exponent x, and that's it. And of course, we have seen that the graph is essentially that b is less than 1 greater than 0. But of course, this one is what we just knew, but we were only given that b is greater than 0. Okay, so that's not a problem. So 4.1, we have to write the coordinates of D. D is the y-intercept of our exponential graph. So D is in this manner, 0 and 1. So if you didn't know how this goes, I'm just going to expand it out here so that you can see it. So well, here you'll just say for y intercept. It implies that x equals to 0, right? Which implies that y equals b to exponent 0, right? So where there was x, you replace with 0. Okay, this is equal to 0. I don't know what I did there. And then we know that therefore y equals 1. Remember, any base to exponent 0, that is 1. Therefore the y-intercept is such that we have 0 and 1. So do you see, this is how you work it out. But they just said write it down because they know they're not interested in a lot of your algebraic manipulation there. So let's go on. 4.2. What is the story here? Write down, again, write. So you don't have to determine, you don't have to explain, you just write. Write down the equations of asymptotes of f. Okay, so we said for the vertical asymptote, we just equate that denominator to 0 and then we solve for x. So we know that the first one is going to be x equals -2. The second y is y equals -1, just the way it is over there. Okay, so that would be the value of q. Again, you get a mark for each, so you walk away with 2 marks. So 4.3, what is the story there? Write down the domain of f. Okay, now let's explore this one a little bit. So if you're looking at the graph of f, which is the hyperbolic function, so where do we see the graph? We see this graph from this point. Actually, we just put an open circle there at -2 because that would be the jump, okay? But we see this graph all the way to positive infinity from that point, and again from that point to negative infinity. So what is that? With just this jump, so I mean there's too many values to consider there. So what we say there is an element of real numbers with the restriction that x cannot be equal to 2. Alright, so we can just write domain is equal to a set of x values such that x is an element of real numbers. The restriction is that x is not equal to, minus 2. Alright, so I don't know why I wanted to write 0 there, so that is just minus 2, okay? Of course, you have options here again if you don't want to write it that way. So, what are your options here? It's the interval, so you can say x is an element of minus infinity into minus 2, right? That union minus 2 and positive infinity, okay? So you can write it in intervallic form, but remember, intervallic form of the domain only applies to real numbers, okay? If you don't have them, say you have integers, you cannot use this, please. Or you have options of inequalities, so you can just write x is less than minus 2 or x is greater than minus 2. So either one of these ways is fine, because I mean you get a mark and a mark. You get a mark and a mark, okay? Or here you get a mark for that and for the restriction. So in essence you have 2 marks. So that's easy. Now we are told 4.4 determine the value of b. So b is the base of our exponential function. Okay, not a problem. We can handle that easily. So 4.4, we know that g of x is given by the power of base b to exponent x, alright? So now through this point E, which was given as 3 is to 1 over 8. This will be such that 1 over 8 equals base b to exponent 3. Okay, so now there's no way of comparing b and that, but the exponent gives us the guide. So can we express this as a power of a particular base to the exponent 3? Yes, we can. So this is a half to exponent 3 equals b to exponent 3. Okay, great. Now with these exponents being the same, and if these powers are the same and they carry the same exponent, what does it tell us? The bases should be the same. Therefore b is a half. And didn't we say that b from our graph was less than 1, greater than 0? Yes, we did. And look at that. It is exactly how we expected it to be. So that's the answer. Not a problem. How many marks were they giving? 2 marks. I think the correct substitution in the final answer is where those 2 marks come from. So, I mean, remember my way of marking this is not exactly how your exams are marked. So it's just a guide so that you can see where are the important steps, so that you make sure you don't mess around when it comes to those points in your solutions, okay? Of course, marks can come from anywhere, but I can tell you, if you make sure what I'm showing you is covered when you answer, most of the time you'll pick the marks right there. Okay, let's not say too much about that. So 4.5, we are told now, determine the coordinates of A and C. So those are the x and y intercepts of the hyperbola. Not a difficult question also. 4.5, we know that for x intercepts, this implies that y equals to 0, right? And which also implies what? 0 equals minus 3 over x plus 2 minus 1, right? Right. And what do? We transpose this constant to this side, it becomes 1. Of course, we're dealing with fractions, so you express it as a fraction of itself. So minus 3 over x plus 2. Now when we get here, the power of cross multiplication, so when we multiply this by 1, all we get is just x plus 2 equals minus 3. Therefore x equals minus 5 when you transpose the 2 to the other side. Therefore a, remember a was the x-intercept, therefore a is the point minus 5 and 0. Sorted. So you can already draw this onto your graph because it makes sense. I mean, this value here is less than minus 2, so it makes sense for it to be minus 5. Okay. So what about y? Let's just create a bit of space here. So for y-intercept, this implies x should be equal to 0, which implies that y equals minus 3 over 0 plus 2 minus 1. Now what I do here, I just take the denominator and multiply the numerator of the next term. I get minus 2 and then I add those two together. It becomes minus 3 minus 2, which is minus 5, then over the same denominator. If you don't know this, you can just put it in the calculator, or this by 1, look for the LCD. Not LCD, but the common denominator, or the highest common denominator. It's fine. I don't want to go there. It's just keep it simple. Therefore, what was point C? Point C is 0 and minus 5 over 2. Okay, so we sorted that. Then we can see that, well, this is a number less than minus 1, so it makes sense. So we can accept it. Okay. The sign, the size is good enough, so what are the chances that it's wrong? They are very small. We may mess up the numbers there and there, but we can accept the answers to some extent. Okay, they were giving us 3 marks, so I think what we did here was kind of critical, and then to show our point, and then here you just get for the answer. So this in essence is all the 3 marks. Alright, so we're good. We are good. Okay, maybe let's create a bit of space also here. Can't just leave it too easily like that. So we can answer the next question there. 4.6 says, write down. Remember, write down. Always pay attention to how you are asked. If somebody says determine, you can't just write, okay? Or calculate, you just cannot write. Or show, you just cannot write. But if you have a question that says write down, even if you just show up with the answer, that's what they want. They're not interested in how you came about that answer, alright? So be very brave when it comes to this one. So what I can do here is, well, 4.6, I know that the inverse of g is such that we have y equals log of x to the base a half. Right? We found that the base was a half. So that is what you need here. So you can get your 2 marks straight away. But someone is going to be wondering, how did you get there? That is fine. For teaching purposes, we can show how this came about. Well, when you do the inverse, you know that the inverse of g will be such that you replace x with y, okay? That was now a half. We found out we had our base as the half to the exponent y. Remember that was x, so you switch the 2. And then you know to solve further here, you can't. You just need to introduce log. So what you do on the left hand side, you also do on the right hand side. Okay, that's what you have. This also implies, now logarithmic rules say if you have a log of a number to a particular exponent, the exponent essentially multiplies that whole expression. So we have log x equals y log of a half. So this is what it tells us. And then to eliminate this log x to the half, the log of a half, we just divide throughout by log of that half. Okay, then this one goes, and this now implies that our y equals, remember, when you have this again, there's another logarithmic rule that says if you have log of a particular number to a particular base, say this is base 10 when it's not written, okay, it divided by log of any other number with the same base as the one above. So all it means is that we have log of the numerator to the base that was the bottom number. So that's what you have. So you have y equals log of x to the base a half. Great. So they didn't say determine or show or calculate. They just said write. So this is what you just do. But if you didn't know how it comes about, you can do this on your rough work and then put it down on your answer sheet. You don't want to waste space there also. Okay, so that is fine. So we have our 2 marks. Let's see if we cannot answer this next question on this side. It's not too dirty, right? Right. Because it's just a few questions anyway. So we have 4.7 here. It says determine the values of x. Always pay attention. What values are you looking for? X. So they are in the domain, okay? For which f of x multiplied by g of x is greater than 0. So when will the y values of f multiplied by the y values of g be a number greater than 0, meaning a positive number? Now we look here. We can see that in relation to this asymptote line, okay, what is happening to these graphs? Well, say to the right of this asymptote, this one is positive, and we're looking for a region where they are either both positive or both negative, right? For us to get a product greater than 0. But this one is negative. Okay, so positive and negative, the product is negative, and this happens throughout this right half, or to this right side of the asymptote line. So that means this is out because the product is less than 0. And then of course we cannot consider this minus 2 because it's an asymptote, so this is where there is a jump on our hyperbola, so we can't evaluate that. But past this asymptote to the left, what do we see? This graph is positive. It's above the x-axis, that's what we mean by positive. That is now the graph of g. And what about the graph of f as well? It is positive. So they are both positive all the way until this point here, when this one is 0 and the product of what is happening here is 0. So we don't want 0. We want a number greater than 0. And of course below this graph is now negative, so we can't take anything from this point to the left. So the region here is here. This is the region. And of course this now is no longer included, as well as that point. So this is the region we want. Okay, how do we express that on paper? Okay, 4.7, and then we have 4.7.1. We know that x will be less than minus 2 because it's not included, but greater than minus 5 because it's also not included. And for that form you get 2 marks. Okay, easy. 4.7.2, what do we have here? When will be the inverse of g of x be greater than and equal to 3? So this one is simple. You don't even need to imagine what the graph looks like. We know that the inverse of g of x is given by what? By log of x to the base half, isn't it? That's what we found out. Okay, now for this to happen now, this implies that for this expression, now let's just say, okay, for g, whatever that is, in fact, just read it as the inverse of g to be greater than or equals to 3, it implies what? It implies that this situation here, log of x to the base half, is greater than, what are you doing? Greater than and equal to 3, okay? Now, to solve for x here, you don't have a choice but to drop the log. So that means you go back to exponents. So you push the base and you push this number as an exponent, because log of a particular number equals what? That is the exponent to this base. It gives us that value, okay? So we know here that therefore x is going to be greater than or equal to a half cubed. So this is what happens when you put this base where it belongs, the exponent goes to where it belongs, okay? So therefore x should be greater than or equal to 1 over 8. That's the answer. So here it's better to solve. Otherwise you'll be forced to draw the graph and investigate this on the graph, which is okay, but it takes you a bit of time because you don't have the graph of that inverse. But it's much easier to just solve for it algebraically, okay? Great. So 2 marks. Again, to make this conversion and to find the answer, this is where the marks are coming from. So this is the easy 16 marks of this question, and we move on. Hope you enjoyed it. Alright, so what do we have here? This pen. Messed up. Okay, let's answer this one easily and quickly too. Alright, so what do we have here? Question 5 gives us the diagram below shows the graph of f of x equals minus. Now remember, once the coefficient of x squared is negative, a is less than 0. So what do you expect? We expect our graph to have a maximum value at the turning point. Alright, so it's a grumpy face. Again, the reason why I'm doing this is because you may find drawn here something else than what you expect, okay? But whatever they would draw there, it would have a relationship with what is given. So these questions can trick you. They're not always this direct, okay? This is why it's important to always read carefully what you are given and look in the sketch. Is it what you expect to see? And if it is so, then you know there's no tricks there, okay? Great, okay, minus 2x plus 8, fine. We know that once it's a plus 8, definitely at this point we have 8, okay? So that v, because it's the y-intercept, it's where the graph cuts the y-axis, it is 8, it's always the constant. Okay, so that's easy. R and S are x-intercepts and v is the y-intercept of f. T is the turning point of f, not a problem. So we can just go on and say determine the length of RS. Okay, RS is a horizontal line. Now a horizontal line is only determined by the difference of the x value here and there. So what are the x values there? They are the x-intercepts. So we need to solve for these x-intercepts first and then find the difference between the two. It gives us that length, okay? Easy. So question 5, what are we given? F of x equals minus x squared minus 2x plus 8. Okay, it's a quadratic. 5.1, we want RS. So we know that R and S are x-intercepts, okay? So you can say R and S are x-intercepts of f, okay? This implies that y equals to 0, right? Which also implies what? Minus x squared minus 2x plus 8 equals 0. And we multiply throughout by negative, we get x squared plus 2x minus 8. So this is just a mathematical trick so that we can have an easy factorization. Otherwise, you can even factorize like that, it's still okay. So what do we have here? We will have x and x. Factors of 8, that will give us the next term here is 4 and 2. But now we want this one to be positive, so it's going to be a plus 4 and a minus 2. And then that's easy. Therefore, x equals 2 or x equals minus 4. Alright. And maybe we can just say, therefore, x at R, because I mean that's what this means. What am I doing? This is x at S. Sorry. See, sometimes doing things you end up messing up, because I mean R is on the negative side of the x-axis and S is on the positive side, so that is the guidance. So we can say, therefore R S is going to be x at S minus x at R, okay, because it's a horizontal line. So it's a horizontal line, okay, which is equal to, what was that? This was 2 minus into minus 4, so this gives us 6 units. So we found our answer, nice and easy. So this was 4 marks, okay. I do feel that first of all, to equate our quadratic to 0 was quite important, because if we didn't have that, we wouldn't know what we are doing. And then forgetting those factors, it's another good thing. And then here, I don't know, maybe it's key to express this formula. The substitution is not that powerful at this point, but the answer. So this is where the 4 marks would be coming from. But remember, like I said, it's just an arbitrary guide of marking here. Just trying to show you where strategically would you get your marks, okay? Meaning when you answer, be very, very crafty. In that certain areas you don't mess around, because this is where you could get marks even if you ended up being wrong along the way. Anyway, we cannot overly emphasize that, so meaning you should show all your steps. That's why it's so important. Anyway, let's keep going. Now determine the coordinates of t, okay? 3 marks, okay, easy here. So I found out that this is minus 4, right? Then I found out that that was 2. So for me, I know that the turning point is halfway between these 2 points. Alright? So I like to use the graph than some formulae. I use the graph more than I use algebra. But it's up to you what you do really. So I know that x at t is going to be equal to x at R plus x at S, all that over 2. That's what I know. What was that? X at R was minus 4 plus 2 over 2, which is what? So this one is minus 2 divided by 2, which is minus 1. Okay. Then what do I know? Y at t is equal to f at minus 1, isn't it? Which is going to be what? I'm not going to show that substitution. You know you need to do that. So this is minus 1 squared. It's 1. And then times the minus there becomes a minus 1. Then 2 times minus 1. Sorry, minus 2 times minus 1. It's a plus 2. Plus 2 minus 1 is 1. 1 plus 8 is 9. Therefore, t is the point minus 1 and 9. So I mean, I'm just using the graph here. I don't want to stress, but you have options here that you can employ. For the turning point, you know that x equals minus b over 2a, and then y equals 4ac minus b squared, all of it over 4a. You have those formulae. You can use that. It will give you the same answer. Or you can say at the turning point, using grade 12 stuff, you know that the first derivative equals 0, and then you solve for x, and once you solve for x, whatever x value you get here, you will then substitute into the original. You'll still get the same. So I mean, these are your options, so you're not only limited to the graph, but I always try to use what I have in front of me before I start struggling to remember certain things, because you don't have this formula, they don't give it to you, you just need to know it. Okay, so let's move. Now we are told, okay, we didn't mark ourselves here, so that was how many marks? 3 marks. Okay, so I would say correct substitution and that, and then finding that value. So this is where the 3 marks come from. Great, not a problem. So 5.3, it's divided into 5.3.1. So what do they want? They're telling us the gradient of a tangent to the graph of f at a point w is equal to 2. And you can tell that this gradient is positive. And where would you find tangents with positive gradients on this graph? On this side. And they will appear above the graph, right? And because this side, they are all negative gradients, so you're not going to consider this side past t, but all the sides before t. Okay, so this w is anyway along this point. Okay, it's not easy here to show the tangent because it's almost like a straight line. Okay, so maybe the best place to try and portray what would be this tangent is somewhere up there. Okay, but let's just not do too much. We're going to cause ourselves unnecessary problems. So it says determine the coordinates of w. So we know that when the gradient of a tangent, so we said here m10 equals 2. Remember that gradient of a tangent at a point is the same as the gradient of a curve at the point. So this implies that the first derivative is equal to 2. That's what it means. And let's do the derivative. So what was our f of x? F of x was minus x squared minus 2. So basically it's going to be minus 2x minus 2, because that one of the constant is 0. So I'm going to have here minus 2x minus 2 equals 2. Why? Because I want to solve for x. So minus 2x equals, when this one comes here, we get 4. Okay, it's going to be 2 plus 2. Therefore, my x is going to be minus 2. Okay, so it's great. So I know that this is when x is minus 2. And therefore, we know that the y value here is going to be equal to f of minus 2, right? Which is going to be equal to what? Okay, let's not do it here. It's always nicer to be orderly. Now, when we put a minus 2 into our original function, this becomes 4, right? So it's a minus 4. When we put a minus 2, that becomes a plus 4. So minus 4 plus 4 is 0. So all we're left with is 8. So this is 8. Therefore, w is going to be the point minus 2 and 8. Okay, so all we can tell is that, great, we can see that this point is a mirror image on the parabola of v, right? And we know that as we read that down, we read it down to minus 2. So we're reading it down to minus 2 here, which makes sense because it's a point before that x-intercept. And it is elevated the same way on the y-axis as point V. So those are mirror images of one another. Okay, not a problem. So the tangent is here. It's passing there. Right? So that is the tangent line. Okay, so you can just write it down here and say tangent, because we don't really care to find its equation at this point. So all we know is that the gradient is 2. Okay, so this is point W, and this point W is minus 2 and 8. Okay, I don't know, it's always nice to write these things in because some questions may demand that. So that was 4 marks. Okay, So maybe that was important to realize and to do the actual differentiation and to solve for the x and to solve for the corresponding y. So that is the most important. Okay, great. So let's see, can't we do this here? We can do it. Next question says determine the equation of a straight line G which is perpendicular to the tangent and passing through V. Alright, so let's see what is this situation now. Okay, so this situation says on our graph we have now a line that passes through this point V but is perpendicular to our tangent line. So we'll show this one in green. So okay, this is the line of G, and if it passes through V, V is what? Is 0 and 8. So that is the y-intercept, and we are being told that this is perpendicular to our tangent. We don't really care what that point is where they come together, but we know that we knew the gradient of a tangent was 2. So remember, that is a straight line, so gradient will remain 2 anywhere on that line. But now perpendicular lines have what? The product of their gradients equaling -1 because they are inverses of one another. So you see, this is a nice question. It's like analytical geometry, perpendicular lines, right? See, they can bring them anywhere. They can bring them anywhere. Okay, good. So we already know that the y-intercept is that. So all we want is just the gradient of this line and we are done. So fine. So 5 point, don't do it. Don't do it. Okay. All right. So this is 5.3.2. Okay. So we know that the gradient of G multiplied by the gradient of a tangent is going to be -1, right? What is the reason? These two are perpendicular lines. Right, perpendicular lines have their gradients multiplying each other to -1. This implies now that the gradient of our G multiplied by 2, because the gradient of a tangent was 2, it was given, equals -1. Therefore the gradient of our graph is at -1/2, right, when you divide by 2 throughout. We can also say G passes through V, therefore the y-intercept is equal to 8. That's all you needed to do. I mean, if you like, you can calculate using that point, it's up to you, but I'm just using, easy way. Therefore G is such that y equals -1/2 x plus 8. Done. That's how you can do that easily. So how many marks were they giving? 2 marks. The most important is the gradient and the equation, because the rest was just too easy to get to. Alright, not a problem. So let's do the last question here and see what we can do about it. Let's try it here. It's not too dirty. It is not that dirty, So this is 5.4. Okay, let's do this 5.4 quickly. So 5.4 says what? The graph of f is shifted 1 unit to the right. 1 unit to the right. So what does this mean? We will have x -1, right? Because if we're shifting 1 unit to the right, that means from all the x values, we subtract 1. That's what we do. And then reflected in the x-axis, we know this is a vertical reflection. I'll just say vertical r. And what is that? It means the whole function. We're going to say -1 into f of x. Alright, so great. So we multiply the entire function by a negative while we subtract minus 1 from each x value. To produce a new function of h, determine the equation of h in the form h of x equals, okay, this is a parabola, you can see that. Alright, not a problem. We can handle that. So all we're going to start with is that it is given that h of x equals what? Minus into, this is the negative for a vertical reflection, or a reflection about the x-axis. And then what do we have here? F of x minus 1. That's all that this means. Okay, now let's solve. We have minus into f at minus 1. Remember the original was minus. Instead of x, you're going to put x minus 1 and then you square, because that was minus x squared minus 2 into the same thing. Where you see x, you put x minus 1 plus 8. Okay, that's what we've got. So we can fix this. Minus into, this is going to be x squared minus 2x plus 1. So if you don't know how to FOIL these things, please practice. This one falls nicely, minus 2x plus 2 plus 8. Okay, great stuff. Then what do we have here? Now we can break these brackets. So when we break this one, we're essentially breaking the big ones. So this is going to be minus x squared plus 2x minus 1 minus 2x plus 2 plus 8. Okay, now we clean what is inside a bit. So we have minus x squared. Then we know that 2x minus 2x, they cancel. Minus 1 plus 2 is just 1. Right? 1 plus 8 is 9. So we have plus 9. So what we have inside is a difference of 2 squares. But of course, we just multiply the negative. It becomes now x squared minus 9. And you can see it nicely. So here you can just make your conclusion. Alright, great. So you can see here there's no bx. It is 0. Alright, that was easy. 4 marks. I think for this expression over here, and to know that you're multiplying by negative, those are the 2 marks, right? Right, and I think working it out to here is great, and the final answer. So this is the easy 17 marks of this question. So these guys are cruising. They had the nicest of questions to handle. Okay, great. That is question 5. So now we're going to go to the cubic function, which is the nice one. I always enjoy the cubic function. It has a little bit more for a student. Alright, so question 8 says the diagram below shows the graph of f of x equals, again, always interpret what you have. So a is greater than 0 because it is 2. That is the coefficient of x cubed. So what do you expect your graph to be like? It starts off increasing, decreases, and increases. Okay, so that's what you expect. Now look at the graph. Is it so? Yes, it is. So there's no tricks again, because they could give you a reflection of that graph instead. So you would need to know what happened. Okay, so that is the story. Fine. And then we have variables there that we are definitely going to be asked to find. Fine, what are we given? Point j minus 1 and 0. There it is. Don't do it. Minus 1 and 0. K is a half and 0. L is 3 and 0. So obviously these are the x-intercepts. And then G is the y-intercept, which we don't know. Okay, of f. Okay, M and N are the turning points. Okay, fine. And H is the point of inflection. Okay, not a problem of f. Right, so the question says now, determine the values of B, C, and D in the equation. So essentially it says find the equation of the cubic function. because from there we'll read all those coefficients we need. Alright, let's just get to it, not waste time at all. So question 8, we start with 8.1. We are given f of x equals 2x cubed plus bx squared plus cx plus d. That's what we have, alright? So now 8.1.1, what do they want? The equation, essentially. That's the question. Although they're just pointing out b, c, and d, but you would get this from the equation, right? So from here we know that f of x can be shown as say a into x minus r1 to x minus r2 to x minus r3, right? And it is given, we know that, but a equals 2, that was given. Don't have to even explain to somebody, but remember, treat your examiner as a person you are teaching mathematics, okay? That way you will convince even someone else about how good you are at this thing, even if you got it wrong, but they will be happy about your systematic approach. Anyway, so this implies what? That our f of x equals what? So this is now 2 into x. Now the first one was j, which is minus 1 and 0, so we're going to have plus 1 instead, because minus 1 is a plus 1, right? Then the next one is going to be x minus a half, okay? Then the third one is going to be x minus 3, because those were the intercepts they gave us. So we just simply solve from here, no problems. 2, let's first deal with these brackets. We will leave this one alone for now, and then break this 2. What is going to happen here? We're going to get x squared minus, so minus 3x minus a half x. What is that going to be? So this is the same as multiplying this. There we get minus 6 minus that one becomes minus 7 over 2x, okay? Be able to deal with this even when you have fraction factors. It still doesn't cause any trouble. So this is going to be this multiplied by that is just going to be 3 over 2. Okay, so there we are. We are sorted. Then now we can do this multiplication again to break these big brackets now. So what are we going to have here? X cubed minus, here we just have to do it the long way, x squared, okay, plus 3 over 2x, and then plus x squared, minus 7 over 2x, plus 3 over 2. Okay, that's what we have. Let's clean it up. X cubed. Now this guy here and that guy, so we're just going to handle those two. Now here you just multiply that, there it becomes 2x squared. 7 minus 2 is just going to be minus 5 over 2x squared. Alright, and then we go and deal with this guy and that guy. Again, here they have the same denominator, so we just simply subtract the top two. So what we have there is going to be 7 minus 3, which is minus 4. Divide by 2, it's minus 2, so it's minus 2x here. And then we just have the last one, 3 over 2. Okay. Then we multiply our 2 inside, we get 2x cubed. So you see, it's there. Minus, when you multiply by 2 here, you get minus 5x squared. Minus 4x plus 3. Alright, so therefore our b is the coefficient of x squared, it's minus 5. Our c is the coefficient of x, is minus 4. And our d, which is the constant, is 3. So this 3 is the y-intercept, so it tells us that the 3 is over there. Okay, great. That's the answer. So that was cool, not a big deal. How many marks? 4. Okay, they felt a little bit generous, so this correct substitution is key. I don't know, man. I would give a mark for getting there, but maybe not. The marks here, here, and here. So that in totality gives us 4 marks. I mean, there's a lot, but we cannot be ridiculous and give you more than 4 marks. But we could. I mean, this is important for me to do. So anyway, it's alright. 8.1.2. Let's move. I'm getting too relaxed now. Now I told, if it is given that f of x equals 2x cubed, doch, they are giving it to us. So now they are telling us that we actually got it all right, because that's what we got. And alright, anyway, so this is the situation. Determine the coordinates of n, the minimum turning point. Okay, that's an easy question. We know that turning points are such that the first derivative is equal to 0 for the x values, which implies, now we do the first derivative, that it becomes 6x squared minus 10x minus 4 equals 0. Okay, not a problem, which also implies we can divide throughout by 2 here. It's a common factor. So 2 there is going to give us 3x squared minus 5x minus 2 equals 0. Of course, I divided by 2 throughout, in case you don't notice. This also implies, let's factorize this thing. Now when we factorize here, I would give here 3x and x over there. But what must I multiply this and add to this to get this one? Obviously, I must multiply minus 2, right? Because I would get minus 6 plus x, I get minus 5. So this is how this is done. Okay, in any case, if you don't know how to do this, there is a method I would like to show you just now. There's a method I would like to show you on how you would get this, even if you didn't know how to place these numbers when there is a number greater than 0, greater than 1 as the coefficient of x squared, because we could not eliminate it. Now all you do, if you are given, say 3x, come on man, 3x squared minus 5x minus 2. So the method here says you multiply this coefficient of x squared by that constant. So when we say this, we get what? So you're going to have 3 times minus 2, which is equal to minus 6. Alright? So all you do, you write this 3x squared here, and then this minus 2, you leave a gap over there. And then you are going to work out some things here and say, what are the factors of minus 6 that can give me minus 5? It's obviously minus 6 times 1, right? Because minus 6 plus 1 is minus 5. So these are the factors you want to write in there. So this is going to be minus 6x plus x. You know very well that 6x plus x gives us minus 5x. So we didn't change anything there. We just played some tricks. Okay? And then here you take the highest common factor. So you can just group these things. You group these two together. What is the highest common factor here is 3x. Now what will remain with inside is going to be x minus 2. Right? Right. And then what do we have here? We have x plus 2. So this is a plus x minus 2, right? It's the same as that. Okay. Now what do you do here? We still have a highest common factor here, which is x minus 2. So we take it out, x minus 2. What do we have left? 3x plus 1, because it's just 1 there. Isn't it the same as that? It is. So this is how you would factorize these. If you didn't know how to place these factors around such that they fall into place, you can just use this. This is called the PAF method. It's product, addition, and factors. as you could see here, we first found the product of this 3 and the constant, and then we looked for factors of whatever we found that would add to the middle term, and we solved by grouping, and eventually we factorized. So that's a cool thing to notice. Alright, so therefore here we know that x is going to be equal to minus a third, not a half, or x equals 2. Therefore we know x at n is the positive 1, right? So this is the positive side, so it can't be the negative. Is going to be equal to 2. Therefore y at n is going to be f of 2. What was f? This was f, right? So let's just put it in a calculator and not cause ourselves unnecessary strain. So we put a 2 there, we cube that thing, minus 5 into 2 squared, minus 4 into 2 plus 3, so I get minus 9. Okay, great stuff. So it's minus 9. Therefore n is this point, 2 and minus 9. Easy, ne? Great. How many marks? 4 marks. So these guys were very generous. Alright, not a problem. I think it's important to do that, to show this and to actually differentiate. Alright, that is important. And then of course to find these two values. The answer is really, it's really the composite of what we got. Alright. Now let's have a look at these next few questions. This one says now 8.3, for which values of x, so that is in the domain, will f prime of x be less than 0? So when will the derivative of our function be less than 0? Now I need you to remember something, that the derivative, the first derivative, helps us to find the x coordinates of the turning points, right? So what was that? So we found that n was 2 is 2 minus 9. So here we have 2. And what are these points? These are the x-intercepts of our first derivative, basically. So here we have minus a third. So these are the x-intercepts essentially of our first derivative. And what was our first derivative here? We found that our first derivative, when we did the differentiation, it was minus 4. Alright. So the y-intercept would be somewhere here. Because I mean this is 9, so it's going to be somewhere there, the y-intercept. And then of course it will turn slightly below that. We don't know where that would be. It doesn't really matter, okay? So I'm just going to imagine, because remember our point of inflection gives us the x-coordinate of the turning point of our thingy here. So maybe around here, I'm not too sure. Let's just do it. Okay, so we know that fine, these would make x-intercepts of our first derivative. And you can already tell that when a is greater than 0, it has a minimum value at the y-intercept. So this is why it's so important to watch that video on my cubic function explanations. Okay, so please do that. Go and find that video and watch it. It will help you a lot, because here you just need to know what's happening, alright? So that you don't lose marks unnecessarily. So this thing is going to come here, pass there, approach this one. Don't have a figure, simply lift off. Well, my attempt results in a figure. I win. So this is how you would overlay the graph of f prime of x. So you need to know this, please. And you know this is minus 4, right? Because we saw that when we did that differentiation, That becomes the y-intercept. So in a way it gives you a guide as to where to go, but the rest is not so easy, ne? Okay, so what is the story? When do we see this graph below the x-axis? Basically, when they say it's less than 0, it's below the x-axis, meaning the y values for each of these x values in between these 2 points have negative signs. Alright, so now that we've sorted that, let's finish off our answers nicely and easily. So we have now 8.1.3a. So we know that f prime of x will be less, what am I doing? Will be less than 0 when x is less than 2, greater than minus a third, okay? Because this is where we see our graph on the negative x-axis, on the negative y-axis. But here it's at 0, and then that side, so meaning this x value is going there and there, the graph would be positive. So see, this is a very nice question. So this form is usually given 2 marks. Okay, let's see. What about B? When is this graph concave down? Now f, the original function. We know we were told this is the point of inflection, so immediately below that point, the x value is below that x value, we know that our graph is concave down. So you can see it on the graph, you don't have to imagine it. So we know that once we find the x-coordinate at the point of inflection, which is going to be that x-coordinate over there. Once we find the x-coordinate over there, immediately below that point, this graph is concave down. And just above that x-coordinate, the graph is immediately concave up. Okay. So how do we solve this one? You have 2 ways here. Now I know for a fact that my x-coordinate of the point of inflection lies halfway between the x-coordinates of the turning points, because we know that the turning point of a parabola is exactly halfway between the 2 x-intercepts. So you see, when you take one on top of the other, you have all the answers. So here you can say this is going to be a situation where x is less than, because we know we want a number less than that value, right? Is less than what? Is less than x at n plus x at m over 2, isn't it? Yeah, that's what it is, which implies that x is less than, what was this one? It's minus a third plus 2. All of that divide by 2, isn't it? Is great. Therefore x must be less than what? Now when you multiply there, you get what? Plus 6, ne? 6 minus 1 is 5 over 3. Divide by 2 is going to be 5 over 6, because 3 times 2 is going to be 6. Okay, maybe it's not so visible. So x must be less than 5 over 6. Okay, that's easy. So you could use the graph, because I'm using the graph now. You could use the graph to do this. So how many marks are they giving? 3 marks for this, correct substitution, and the answer. So 3 marks. Of course, if you didn't know this, you have an option of knowing that always the graph of a cubic function is concave down when the second derivative is what? Is less than 0. Because when this first derivative is greater than 0, the graph is concave up. Okay, so which implies now when we do the derivative of a derivative, so when you multiply they will get 12x, right? This implies that 12x minus, now this one is going to be minus 10, is less than 0, right? Which implies 12x is less than 10. Therefore x is less than, when we divide by 12 here, 2 goes to 10 5 times, to 12 6 times. So it's the same answer. So I mean for this and the answer, and of course the actual differentiation. So this is where the 3 marks come from. Alright, so I hope you can see that. I mean, you can use the graph, you can use theory, you will still get the answer. Not a problem. So let's do 8.2. Okay, it's one of a very interesting question. So 8.2 says g of x equals px cubed plus qx squared plus rx. Now notice something here. There is no constant. And if there's no constant, this implies that the y-intercept is the origin. Right? Because if you say for y-intercept here, means x is 0. So when you substitute 0, you get 0. So 0 is going to be 0. So essentially they're giving us a y-intercept. Then we are told p is less than 0. So you know that p is less than 0. So when a is less than 0, so we can just imagine p as a, right? When a is less than 0, our graph is decreasing, increases, and then ends up decreasing. So you expect that shape. So this next piece of information gives us the shape that our graph is like this. Okay. Now, we're told also g prime m. Remember, g prime m is a gradient at point m on the function of g. Okay. So they're telling us that that is equal to 0. So you know that when the first derivative at a particular point is 0, that point represents a turning point. So this is a turning point. But this turning point is also equal to g at m. So when we substitute for the corresponding y value at m, it gives us what? 0. So this is an x-intercept. So you know very well that when an x-intercept becomes a turning point at the same time, then you have 2 equal roots there. So they are telling us that m is greater than 0. So obviously it would be this point there, probably. Now it says draw a sketch graph of g, clearly indicating one of the turning points of g in terms of m and all intercepts. Okay, great. So we know we can solve this. So again, you would know this by knowing what is the interpretation of the given information. If you don't know this, it's going to take you down. So don't cry. Do not cry. Alright, so we will have x. So this is the origin. That is the y. So what are we given here? Not f, but g of x equals px cubed plus qx squared plus rx. Okay. Of course, we know that our graph will pass through the origin, and then of course it's a decreasing function. So if we imagine they told us m is greater than 0, so here we have m greater than 0. So this one is a turning point as well as an x-intercept. That also tells you the x-axis becomes a tangent to that point. Alright, so our graph is doing this. Remember, it's a decreasing function. So it's going to decrease, 10, approach that point, and then 10 back down again. So how do I know it's going to turn down? Obviously from the shape. So this shape, I know very well that once it turns, when it turns again, it turns down. So I'm not going to worry about how do I know it's turning down. It's a cubic graph. So the characteristics of A already tell me that this is what is happening. Of course, this turning point is an x-intercept as well as a turning point. Okay, and there's 2 equal roots here. So that tells us this is yet another root, which is the origin. So we've labeled it. Not a problem. So this is the graph of G. I think we are done here. So this is the sketch. So 3 marks, I think, for the shape, for that x-intercept, as well as that x-intercept, it also serves as a turning point. As for this one here, we don't have to know what is happening. We don't care. So these are our 3 marks. So this marks our 16 marks of this question. So it's very easy, né? Don't lose marks on this type of questions. They are easy. Easy, 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 easy. You don't have to lose anything here. Okay, let's quickly do the last one. I like it because it's an application of differential calculus. So I never leave this question when I do these. So I hope you're going to enjoy it as well. So I'm trying to do as much of this paper as possible. So in the diagram below shows a solid triangular prism. So once it's saying solid, it's not hollow. So there's no open space. So it's a solid triangular prism. Again, triangular. That means the basal surface area here is the triangle. And then the rest, it doesn't matter, okay? Now the triangle is right angled, okay, with a height of 8x meters. So we can see it's drawn in. The base is 15x meters, it's drawn in. And the hypotenuse of 17x meters, okay, that is written up there, not a problem, as indicated in the diagram for sure. The length of the prism is y meters. Again, it's drawn in. Okay, so this y meters is from here to there. All right. Now, the total surface area of the prism is that number there, 5,760 meters squared. All right. So what can we do with that? Now they're telling us, fine, show that y equals this expression. Now we know that this is going to come from the area. So how many surfaces do we have to consider? It's this surface as well as that surface, but on the other side. You see, on the other side, because we don't see, but we're just having an X-ray vision. It's a 3D structure. All right, so we're going to have 2 of these plus this surface here because it's facing us, and then this other surface over there at the back. I'm just going to write it there. But that is this surface on the other side that we don't see, as well as this under surface, which we're also having an X-ray vision, but it's actually underneath. It's right over there. Okay, and then we know that this one is over the other side over there. Okay, great. So how many surfaces are we going to have to consider here? 1, 2, 3, 4, 5 surfaces. So we have to add those surface area or areas to get the total surface area. But we know that this one is doubled, so we just take this one and multiply it by 2, and then we add these others because they are not equal. We don't know. No problems, no problems. So question 9, what do we have here? So we know that, okay, fine, A tot is going to be equal to, the A total is going to be equal to 5,760. So that was given. But what does this imply? Now A tot is the triangular surface first. So we know that this is going to be half base, which is 15 meters, 15x meters, times the perpendicular height, which is going to be 8x meters or units. All right. Great. So we start with this one. But we know this one is also doubled, so we multiply that times 2. Great. Plus what? Now it's going to be this backward, or the surface area behind. What is the breadth? The breadth is this 8 meters. The length is that y meters because it's triangular, right? I mean, it's a rectangular. So it's going to be length times breadth. So length is y multiplied by the breadth, which is 8x meters. Plus, now we come to this surface that we see here. This surface has the breadth as that hypotenuse side, which is 17 meters, and the length, which is y. So it's going to be y multiplied by 17x meters. Plus the last surface is the under surface that it's sitting on. And what is the length of that surface is the same as that y, right? So it's going to be y multiplied by breadth. Breadth is this basal surface of a triangle, which is 15x. Okay, that is it. And then all of this is equal to 5,760. Great. So it's a very long and annoying expression here. This implies we know that 2 cancels the 2. So all we have here is 15 by 8, which is 120, I think. Yeah, boo. So here we have 120 x squared because it's x times x, alright? Plus here we have 8xy, right? Plus 17xy, right? Plus 15xy, right? Equals 5,760. Cool. Not a difficult thing to do here, which implies what? So these ones are like terms. We can add them together. So we have 120 x squared plus. Now we have 8 plus 17 plus 15, which gives us 40xy equals 5,760. Now we want to solve for y, so we transpose that guy. So we know that 40xy equals 5,760 minus 120x squared. Then we divide by 40. Alright, right. Actually, let's leave 40x, actually 40x. Maybe let's just do this, because that's how the expression was made before we put ourselves in danger. So this 40x cancels. Therefore y equals, now what is that? It's 5,760 minus 120 x squared all over 40x. Okay, and that's what they said we must show, right? So it's true. So they were just giving 2 marks. I think the first one is to express all of those area, and and I don't know. So let's not stress here. Some questions are cumbersome. So that was 9.1. Okay, 9.2. What is going on for 9.2? 9.2 says, hence show that the volume of the prism can be expressed as v of x, so it's a function, right? 8,640 x minus 180x cubed. Okay, so the volume, remember the volume is the space inside this thing. Now the space inside this thing, you follow what was given. It was not a rectangular prism or a cone whatsoever. This is a triangular prism, so that means the basal side is the triangle. Then you'll use the length. So you know that the area of a prism is the basal side, which is the surface of the basal side, multiplied by its length. Okay, so we know that the volume in terms of x of this prism is going to be equal to the area of the base. The base is triangular, so it's 15x multiplied by its height, which was 8x. Okay, this is multiplied by the length, which is y. Okay, great. And we know that this guy and that one, they cancel. Alright, so what do we have here? 15 by 4 is 60 x squared. Now into, instead of y, what did we found y to be? Is 5760 minus 120 x squared all over 40x. Okay, so we just substitute for y over there. Now we know here that find 20 to 40 goes how many times? 2 times. 20 to 60 goes how many times? 3 times. Okay, so we're solving now, and then this takes down that x at the bottom, isn't it? Because this is divisible. So now we have here 3x into 5760 minus 120x squared over 2. Alright, right, now we can break this say we have 3x into, now we have 7, this is 5, great, 5760 over 2 minus 120x squared over 2. Alright, so you just have to work your magic here. And then this is 3x into, let's solve what is in there now. 5760 divided by 2 is what? Is 2880 minus 120 by 2 is 60x squared. Alright, not a problem. And then we finally do this. So this 1 times 3 is what? Is 8640x minus 60 by 3 is 180 x cubed. Isn't it what they said we must show? Definitely it is what they said we must show. So that's the answer. Okay, they're giving 2 marks. I don't know why. Maybe correct substitution here. Okay, 2 marks, not a problem. Last question. Says determine the value of x for which the volume of the prism will be a maximum. Obviously you know that you want the first derivative equal to 0. Okay, maybe let's try and do it here because I really don't want to waste time. So for 9.3 we know that V max, the volume at the maximum, is such that V prime of x equals 0, right? Right. And what was the volume? It was that one. So let's differentiate here. When we differentiate here, we get 8640. The x goes away, right? Minus, when we multiply 180 by 3, what do we get? 180 times 3 is 540. So we get 540 x squared, isn't it? When we differentiate, this is equal to 0. Okay. So what do? We can take this to the side and rearrange. So we know this implies that 540 x squared equals 8640. I just transposed this to this side, it became positive, and then I flipped it, which is rearrangement. So no crime done there. So here I divide by 540 goes, which implies that x squared equals, now let's see what is that value there. This is like 86 divided by 5, isn't it? Because this takes that, that takes that, and all we left is 86 divided by 5. See? Mathematics, man, is cool. What is that? I messed up. Okay, guys, forgive me. Sometimes it's silly. Okay, it doesn't work, so let's not do it. Let's not do it. It's dangerous. So let's just do the whole thing. 8640. Okay, forget what I was doing. Sometimes you get carried away. Okay, it's back. So don't get carried away. It's dangerous. See, sometimes you'll do a good thing and then you mess it up. So I get 16. Therefore, you know here you will take the square root, isn't it? Therefore, x is equal to plus or minus 4, right? But you can never have a negative meter. There's no negative distance. Therefore, x equals 4 meters. Because that was meters. They told us, so it's 4 meters. So how many marks? 4 marks here. So I think to say that and to do the actual differentiation and to get this answer and to single out that one. That's the 4 marks. So this sums up the 8 marks of this question. So I hope you guys had fun. Otherwise, this was a nice paper, a very good one for practicing for your final exams. Okay, so this was a good trial paper. Alright guys, I hope you enjoyed the video, and like I said, I advise you to go and watch those videos on the individual functions. Trust me, they will make something better in your understanding of how these functions work, and that means you can take any challenge that is brought forward in the exam. So I'll do yet another paper and see if it will be a good one, but I'll try and look through all these papers in the years, and then if I find something interesting, then I'll present it. And if I find another paper that is interesting, I'll probably do it as the last one. So maybe I will do 2 more papers. But if I don't find an interesting one, then I'll stop there. Okay. So the next station from these functions, we're going to go and handle probabilities and the fundamental counting principle. But those ones I'm only going to do videos on just answering the past exam questions. I think those things are too simple. The challenges are just, in and around someone's understanding. So we'll just get into them and just do. But maybe if later I find, some time to teach this as well and make videos on to how you would go about understanding what is going on, maybe I will. But I feel like these ones are easy to just jump into and see how they work. And from how I work them, I do believe you'll find a way of really cracking them every time they come to you, alright? As well as financial maths, we're just going to go straight into the past exam question papers and not really try to waste time making lessons. I think those ones are self-explanatory, so all it needs is just how to solve the challenges. Alright guys, bye-bye, see you in the next video, and thanks for watching. And I can see the response is quite positive. I'm motivated to work harder to present these videos because I can see a few people are really subscribing, and that tells they find these interesting and useful. So I'll do my best to improve even to give you high quality videos, because at this point the quality is not that very good, but it's something that you can work with for now. But in future I'll probably devise some high quality videos for you. Bye bye guys, see you in the next video.